Hello everyone, welcome to day one of Unit 2B. So the second half of Unit 2. We are doing inequalities this unit, so we're going to start with multistep inequalities. Let's go through some vocab first. An inequality is a math sentence that compares two expressions. And here's an example. Okay. A solution to an inequality is any value for a variable that makes a statement true. So, if we solve that, or if we plug in 20, 20 is actually a solution that would make this true, because 23 is greater than 14. Inequalities have multiple solutions because in this inequality, there are lots of numbers we can plug in for x that would give us something that's greater than 14. Okay? Inverse operations are opposite operations that cancel each other out. So like adding 2 or subtracting 2, multiplying by 3 or dividing by 3, those are inverse operations. And step builder notation is the formal way to present your solution or solutions. Okay? So normally it would be x such that x equals blah blah blah, whatever we found. This time it's going to look a little different because we're not talking about an equal sign, we're talking about an inequality. Okay? So, when we solve inequalities, we solve them just like we do equations, using inverse operations, and we follow SADMAG. Okay? The only difference from equations is we have a special rule, that if you divide or multiply both sides by a negative number, you must flip the sign. You could just write negative. I don't know why I wrote number when it's already here. You must flip the inequality sign. Okay? So, to solve multi-step inequalities, we still follow distribute, combine, and solve those steps. So we have to distribute first, then combine any like terms, and then we'll use SADMAG to solve it. Okay? So this is really example 1. I don't know why it says example 2. We're just going to go with it. We're going to solve the inequality and write our answer in step builder notation. And we're going to graph it. Okay? So the very first thing I need to do is distribute this 5. So I'm going to distribute it to the negative 3x and to the negative 5. So now it becomes negative 15x minus 25 plus 15. Next, I'm going to combine my like terms of negative 25 and 15. So I get negative 10. And now I can use SADMAG to solve it. So the first thing I would do is add 10 to both sides. I get negative 15x is greater than or equal to negative 75. And divide both sides by negative 15. I'm dividing by a negative, so that means I'll have to flip my sign. So I get x is less than or equal to 5. Okay? So what this answer tells me is it's telling me all the stuff, like the rule that a value has to follow to be a solution. As long as the value you're plugging in for x is less than or equal to 5, it will make this statement true. Okay? So because there's so many numbers that are less than or equal to 5, we don't write them all out. We don't say x can equal negative 4 or 4 or 5. We don't write them all out. Okay? Instead, we're going to use this answer as like our rule that x needs to follow in order to be a solution. So when we write this in step builder notation, we're going to use this inequality in our answer. So we just write it x such that x has to be less than or equal to 5 to be a solution. This is the reason we do step builder notation. When there's too many to write out, we can just say it's every x as long as x follows this rule. Okay? It's any number as long as the number follows this rule. Okay? And then to graph this, I would number my number lines. So I can't remember where I put it. Oh, right here. So I have 5. I definitely need 5 because that's my placement. And I'm going to number everything else around it. And because it is less than or equal to, that equal to part, that also happens. That equal to part tells me I'm going to put a a closed circle on 5. Ooh, didn't do it. Closed circle on 5. And less than means I'm going to point to everything on the number line that's smaller than 5. So that's my graph. Okay? Now you guys are going to try the next one on your own. You got to do step builder notation, graph it, and solve everything. Okay? Go ahead and pause the video and try that now. Alright, our next example, same thing, multi-step equation. This one just has variables on both sides. But we're still going to treat it just like a multi-step equation. First thing I'm going to do is distribute this -2. Okay? So I have 4x minus 2x minus 6 is less than 5x plus 6. Now I'm going to combine my like terms of the x's, and I get 2x minus 6 is less than 5x plus 6. Now I'm going to subtract 2x from both sides. It does not matter which one. Like, you could also subtract 5x from both sides. It's up to you. So I get -6. Where'd it go? Is less than 3x plus 6. So now I'm going to subtract 6 from both sides, and I get -12 is less than 3x. Finally, I divide both sides by 3, and I'm going to go way up here. I get -4 is less than x. Okay? However, that's not really helpful when we have to graph. It's not helpful when we have to do step builder notation. So, following, I think, symmetric property, which says we can flip it and it means the same thing, we can write the x on the other side, but we have to make sure we flip the sign. The alligator still needs to be eating the bigger number. Okay? So I could write it as x is greater than -4. That means the exact same thing. Okay? So I'm going to use it with the x on the front for my set builder notation. So, set of x such that x is greater than -4, that is my answer. That's my set builder notation and everything. So now I just need to go ahead and graph it. So I'm going to do -4 first, right there, and I number some stuff. Where's all my other numbers? Anyway, just number it out. And then I'm going to do a open circle this time because it's not equal to, it goes up to -4, but it doesn't actually equal -4. So if I tried to plug in -4 in here, it wouldn't work. It would say like 6 is less than 6, but that's not true. Okay. So when it's not equal to, I'm going to use an open circle. And I'm going to point to everything that's greater than -4, so on this side. Okay? And that would be my graph. Not too bad, right? And you guys are going to try this one on your own. Step builder, graphing, solving, all the kit and caboodle. I don't know what that's called, what that means, but. So you're going to do that. Go ahead and pause the video, and when you're done, we'll move on. Okay. So inequality word problems. This is day of notes I kind of had to smush in here because we lost today. So we are going to do word problems, but in order to do that, it's helpful to reflect on translations, what it means. So when we're dealing with inequalities, there's 4 possible inequality signs we could be using. Less than, greater than, less than or equal to, greater than or equal to. Okay? And those are pretty obvious. However, there are also ones that we don't typically use when we talk to people. Okay? So some other words that describe less than would be fewer than. Okay, they might say fewer than. It means less than. Okay, not equal to. Something else other than greater than would be more than. Sarah wants more than Connie. Okay, so that means she can't be the same as Connie. She has to have more. Some other words for less than or equal to: no more than, so cannot go over. At most, again, cannot go over. Maximum, those are all words to describe just less than or equal to. Greater than or equal to has got a couple. No less than, so cannot go below this number. At least, has to be this number or higher. And minimum. Okay? Alright, so knowing those translation words, let's go ahead and try example 1. We have to write the inequality to represent the situation, and then we can solve it. So Tommy mows lawns and cleans pools during the summer. He earns $20 per lawn and $9 per pool. He needs $1,500 to buy a car from his friend. If Tommy mows 41 lawns, how many pools does he need to clean to earn at least $1,500? So I'm going to go through and I'm going to underline important stuff. So $20 per lawn, $9 per pool, at least $1,500. Why is this not? Meh. None of my stuff is clickable. Click it. There, $1,500. At least should be underlined, and it's not. Oh wait, did I do it? Whatever. That should be underlined. He's mowed 41 lawns. At least that should be underlined as well. Please underline that. Oh no, something's gonna happen. Alright. So now I'm going to write my inequality. Per should be your hint that you're multiplying. So I know I'm doing $20 times the 41. $9 times I don't know how many pools. So 9 times X. At least is greater than or equal to 1,500. Okay? 20 times 41 for the lawns, 9 times P for the pools, and that, how much he actually earns, has to be greater than or equal to how much he needs. Okay? So now I can go ahead and simplify that and just do the multiplication. So I get 820 plus 9P is greater than or equal to 1,500. Now I can just solve. I'm going to subtract 820 from both sides. I get 9P is greater than or equal to 680. Divide by 9. This poor kid has to clean more than 75.6 pools. So if he actually cleaned 76 pools, he would have just a little over 1,500. Okay? So really we should be writing... Ooh, what did I just do? Got rid of all of it, didn't I? Yeah, I did. All that fun stuff gone. Alright, well that's the answer. If you missed it, you could just rewind. But he actually needs to clean 76 or more pools. That's how many pools he has to clean. Because he can't really clean 0.6. I don't know who's going to pay him for cleaning 0.6 of their pool. So he's really cleaning 76, because you have to be greater than 75, so the next one up is 76. You guys are going to try this one on your own. Alright. Now we're going to do the same thing, but for a flower shop. Looks like Sarah has at most $30, so at most is something, to spend in the greenhouse on flowers for her summer garden. Orchids cost $2 each, and mums cost $3 each. If Sarah buys 8 orchids, how many mums can she afford? So again, we're comparing how much she is actually trying to spend versus how much she has to spend. Okay? What she's buying is 8 orchids for $2 each, so each is a word that means multiply. So 2 times 8 plus, I don't know how many mums she's getting, so, but $3 each, so 3 times the number of mums she's got. And that, what she's spending, needs to be at most $30. Sorry, I had to pause and I don't know where I left off, so this sounds really weird to you, I know. So, it's $2 times $2 times 8 orchids, plus $3 times M, or X, or whatever it is. And that's how much she's spending. Now, how much she's spending has to be at most $30. So she can be less than $30, she can be equal to $30, but not anymore. So that means we're going to use a less than or equal to symbol. Now we're going to go ahead and simplify this. 2 times 8 gives me 16, and solve the equation. Subtract 16. So I get 3m is less than or equal to 14. Divide by 3. M actually equals less than or equal to 4.7 mums, but we're not going to buy 0.7 mums, so she can buy 4 or less mums. Mums are flour, in case you're wondering. That's how many she can buy. She can buy. Or she can afford, I guess. She can buy 4 or less. Alright, you guys are going to try this on your own. I would strongly suggest practicing trying to write it what it means in the real world, not just the numbers. Okay? If you have any questions, write them down. We will go over them next class. Okay? Bye. Bye.